Hello and welcome to this CNDM session. Civo deploys StorageOS to support its lightning-fast managed Kubernetes development and deployment service. It's great having you here, and for everyone who's watching this live on YouTube, please say hello, participate in the live chat, and let us know where in the world you are today. My name's James Spurin, and I'm the product evangelist for StorageOS. And I have a mixed background that covers a variety of areas. So enterprise storage, automation, DevOps, and software development. I previously worked at Nomura, Goldman Sachs, and Dell EMC. I'm also the technical author of Dive into Ansible. And if you like, you can connect with me on Twitter. My handle is there at James Spurin. Okay, so Alex, over to yourself.
Hi there. So my name is Alex Jones. I'm the principal engineer at Civo. I also, in my free time, am a tech lead for the CNCF's tag app delivery. And I have worked at places such as JP Morgan, American Express, Microsoft, British Sky Broadcasting. I've worked as an engineering director, a VP of SRE, and a bunch of other roles in between. And as was mentioned by James, please feel free to reach out to me on Twitter afterwards.
Brilliant. Thanks, Alex. Okay, so for today, this is the agenda that we're going to be following. We're going to talk about StorageOS, and then this will be followed by a demo by Alex, where we're going to cover what kind of storage problems you encounter, what are the key things you look for in a storage system, how Civo has utilized StorageOS, and a demonstration of a cluster launch. Okay, so the challenge and the journey. Containers, as you know, they solve problems. So, for example, they ease development and deployment. You can encapsulate dependencies, and all of this allows applications to be portable. Next, we have the orchestrators, where Kubernetes has won the orchestration race and is the de facto orchestrator. It's declarative, so we can define the desired state and let the orchestrator handle the details. It also lends itself well to self-service, allowing engineers to easily manage and deploy applications. We then have stateful workloads. Now, most applications store state, but Kubernetes doesn't offer great options for stateful storage by default. And this is where StorageOS comes in and brings us to the last pillar here, where StorageOS is an enabler, providing highly performant cloud-native storage with features such as encryption and compression. So StorageOS in a nutshell. Breaking this down here, we have the reference to Kubernetes. StorageOS integrates with Kubernetes using the CSI driver. So you work with StorageOS in the same way you'd expect to work with Kubernetes. It's declarative and using YAML. There's no other management or external components that you actually need to use here. We have highly performant, deterministic, low latency. So your application runs as you actually expect it to run. We're scalable, and we achieve this through what is known as disaggregated consensus. So essentially, every volume is independent, and thus management decisions, etc., are handled independently, allowing us to scale en masse. On the top right there, StorageOS is highly available with cross-node volume replication. It's agnostic, so you can run us on any Kubernetes distribution that has the standard Linux kernel. We're integrated, so to elaborate on this, you can use us with the likes of OpenShift, AKS, EKS, and other cloud providers. Lastly, we bring features to Kubernetes for storage that you wouldn't get with Kubernetes. So, for example, there's encryption at rest and the options to use the likes of compression. I mentioned this briefly, but to elaborate, I mentioned briefly, but to elaborate a bit further, StorageOS has no kernel dependencies. So as long as your Linux distribution is using a modern kernel, which it will be if you're using Kubernetes, then StorageOS will work. We covered platform agnostic, and as I mentioned, you can run StorageOS on OpenShift, EKS, AKS, other cloud providers, or even on your own infrastructure like Civo is doing. It's lightweight, so StorageOS is both lightweight in its deployment and its use. So it's around about 40 megabytes for the container image, and the minimum requirements are 1 CPU core. At the bottom, we have all of our nodes, and these all have StorageOS enabled. The middle, the green row, represents the pool, and within this, we're aggregating the storage available from each of the hosts below. Then when an application runs, it can leverage the pool and run against any node in the cluster. Okay, so great. Alex, I'm going to hand over to you now for the demo.
Fantastic. Thank you so much. I hope you can see my screen. So let me start by explaining some of the problem landscape that Civo encounters, or any cloud provider encounters, when you're attempting to have tenants within your infrastructure. But to do that, we have to take a step back and understand how we actually solve the problem of running tenanted K3's Kubernetes clusters. Effectively, the way that Civo does it is we have large superclusters, regional level clusters of 28 or so super high power compute nodes with a control plane behind them. And these will then run on top of them through KubeVirt, virtualized clusters that network together. And these can be distributed on various nodes for resilience, and these will all be backed by volumes. And so therefore, the problem space is, how do I make sure that I can have distributed volumes that are replicated in a way that if I have to destroy a physical supercluster node, I don't lose my tenant clusters? And it sounds like a fairly complex problem, and that's compounded even more by the fact that this replication has to be extremely quick. You need to be able to replicate hundreds of gigs of data every day across the cluster as you're moving these nodes around and as you're spinning up new tenant nodes. So really, to encapsulate the problems, I've put a little ledger here on the right. We run effectively hundreds of these tenant clusters within Civo, within each region. And within these clusters, they'll have half a dozen PVCs. So that means we're running thousands of persistent volumes across dozens of nodes, and we need multi-node net replication on those nodes and off those PVCs. And this is also in the framework of us running hyperconverged infrastructure. So that effectively means that our infrastructure is homogeneous. So that within the rack and our open compute, they all have the same kind of specifications. We don't have specific storage clusters. We instead go for a model where each of these compute nodes is templated with dual NVMe drives that StorageOS makes use of. And so to give you a high level of what we're going to look at, we're going to provision a cluster, but I want to explain actually what's going on behind that. So before I go to the Civo UX and click Create Cluster, what will happen is once I hit that subsequent call is we'd get an API request to create a new CRD. So that's a custom resource within Kubernetes, and our operator deployments would fulfill that. But one of the most intrinsic parts is that the storage layer and the persistent volume attaches extremely quickly, because as I mentioned earlier, we use a technology called KubeVirt that allows you to connect to the underlying hypervisor of the currently running node and to provision a VM. But when it provisions that VM, it needs to load in a data image and a disk image, as well as some storage. And this is where we have these types called data volumes, and those are backed by PVCs, and those PVCs live on nodes. And StorageOS takes care of this entire part of our stack. So it's really fundamental that this is extremely quick, because every second you add on to this is a penalty you pay for starting cluster launch. And it's a pivotal part of our business model, is to have extremely fast launch times. So let's have a look at what I've just described. But before we do, one final thing is to say that if we think about the problem space that I just mentioned in terms of these really large existential issues, I'm going to sort of talk us through, as we watch the cluster being built, some of the things that we can accomplish with StorageOS and some of the things that have been really helpful for us to get off the ground running. So let's create a new cluster. I'm in our London region here. I'm going to create StorageOS Civo demo. And we will create a medium-sized cluster, and we will deploy just Redis on it, I think is a good example. We have a few different tools in our arsenal, and one of which is to provide PVCs not only from the supercluster into the tenant clusters, but also inside of the tenanted K3s cluster as a storage class. So that is called a Civo volume, but fundamentally, it uses the same StorageOS provisioning under the hood that allows you to, from your cluster, utilize a PVC that's also managed by StorageOS. So we allow our customers to create databases and have replicated secure data through StorageOS. So that's now creating. Let's go to behind the scenes and see what's going on. So here I have our current Civo clusters in London. I'm going to look for our StorageOS demo. So you can see that we've got a cluster here called StorageOS Civo demo. And what's interesting is you see we've got VM2XFS replicas. So I'm just going to show you what that means. That is a storage class type. And what you might have noticed is it has XFS in the name, because we've got an XFS file system being provisioned on top of this. So this means that we are running two replicas of this storage. So whenever you provision a PVC, that will be replicated twice. And this is being done by StorageOS. So if I go to pods, we can see that if I type in StorageOS, so we've got now our containers are being created. These vert launchers are the KubeVirt process. These vert launchers would not start unless they already had underlying PVCs mounted. So if I click into one of these, we go to PVC, you'll see that, in fact, I clicked on the wrong object. I'll go back into that. At the Civo instance level, which is how we manage what the identifier for a VM is and a pod, we have a definition of the PVCs that are in use. So if I look at Civo instances, I'm going to look at our StorageOS cluster. You'll see a similar kind of example. So here we go, StorageOS Civo volume, Civo demo. And you can see here that it has a little bit more information. So if I go down further into this, I will just try and find the volume. Let's go to mount. I think it might be, oh, I'm sorry. Let me just back out of this. What I'll do is I'll show you at the namespace level instead. I wasn't familiar with how this was set up this morning. So there we go. Let's go demo. So now we've got our cluster running. I'm going to go to this customer namespace and just identify. In fact, I'll tell you what I'll do. I'll just go to the PVCs directly. And this is just a comment on how many PVCs we run in this region. If we go persistent volume claims, we should see we have, about 1,785 running. And those StorageOS back persistent volume claims up and running very, very quickly. Already they're almost 3 minutes old with me faffing around trying to find the right command to show you. As you can see, that those volumes are bound very quickly. All of our volume attachments are managed by the StorageOS CSI attacher. And again, if I go to my cluster, I can see that it is operational. So I go back to the UX, the StorageOS Civo demo is running, and we can download the kubeconfig, and we can then use our cluster. But again, just to emphasize those points again, the process of provisioning and the ability to quickly attach storage to our virtual machines that then create our K3s cluster nodes is imperative. And having the capability to then offer customer exposed storage volumes is really crucial. And so that's how we achieve a really large scale of success and very, very quick provisioning. Cool. Thank you. You're muted, James.
Here we go. Bear with me just a second. Sorry, skip through these. Okay, thank you, Alex. That was really, really good. And it's great to see behind the scenes with everything that Civo is doing there. And in particular, the 1,785 volumes, I think, that you actually had running there. So, yeah, really, really good. So if after seeing this, you want to get started with StorageOS yourself, please visit our website. And if you fill in the form there, one of our team will reach out to you to actually discuss and go through the next steps with setup. And outside of that, I'm going to leave you with some useful resources and some more information on StorageOS. So just on the top left there, we've got the performance benchmarking cloud native storage solutions. This is a report where we were actually compared with other persistent storage providers for Kubernetes, and you can see how we actually compare and perform. At the top right, so if you haven't had enough information on how Civo is using us, please check out this, the actual link there for some more information. And also on the Civo channel, there's some really good YouTube videos where it also goes into detail with the setup with StorageOS again. So they are really good to see. The bottom left, we've got the platform architecture overview. There's the documentation. And on Slack, if you wish to actually speak to any of our engineers, please go there and you can speak with myself, you can speak with the others. We'd be more than happy to help you out. And at that point, was there any questions that actually came in, Michael, as that was going through? Michael, you there?
He posted in the chat.
Okay, bear me a second, sorry. Okay, brilliant. All right, well, I think that's all from us for now. Thanks very much.